Okay, good afternoon everyone. Thank you very much for being here today. I hope everyone's doing well in these tough times. My name is Mohamed Elsakawy, and today I'll be talking to you about open source and advanced research computing in Canada, and as more specifically on how we use open source software to deliver platforms for our end users. And I'll finish by the lessons learned that I'd like to communicate to you about using open source in ARC. So firstly, advanced research computing in Canada, it started a long time ago, mainly with supercomputers. Right now we still operate supercomputers. We have 4 major supercomputers listed on the top 500 list. Between them there's 251,000 physical CPU cores, thousands of GPU devices as well attached for particular workloads such as machine learning. We also have FPGA devices to be used when needed. We've emerged, as I mentioned, over the years from only a supercomputing model to also have cloud deployments. So we started 6 years ago as a cloud deployment, and then we evolved from that to have 4 major cloud deployments right now. Between them, there's 16,000 physical CPU cores, around 6.4 petabytes of Ceph, and we also allow users to provision VMs in the cloud with vGPUs and FPGAs when needed. We also have the other software within our stack, such as VDI, Database as a Service, Platform as a Service, which are part of the regular stack that we provide to our end users for use for the computational workloads. So ARC in Canada is open source at heart. We try as much as possible to use open source software when possible. We have large suite of open source software within our stack. Within our HPC systems, we use Linux. We use Slurm Scheduler, which is an open source scheduler. We use Lustre file system, which is also an open source high performance file system. And very recently, we started investing time in Robinhood Policy Engine, which allows us to do hierarchical storage management within Lustre. Our cloud deployments are based on Linux. We use OpenStack Cloud Enabling Platform. We use Ceph for our storage, and we use OpenStack Ansible for the unification of our deployments. So basically use one tool to deploy our clouds everywhere, and this way we were sure that it's a unified way of managing and support as well. So again, where is open source is? It's basically everywhere. Our infrastructure, we have operating systems, HPC and cloud frameworks for our day-to-day operations. Our monitoring stack, whether we use for visualization, Grafana, Prometheus, configuration management as well. Even our processes as well have open source in them, such as ticketing systems, we use OTRS. Documentation, we're very heavily reliant on Wiki for that. So using open source in ARC is a bit of a big advantage. It actually has lots of advantages with it, but there is 3 main lessons to learn when using open source in advanced research computing, which I've learned over the years. First one is avoid instant adoption, and secondly is talk to your customers, and thirdly is getting involved in the open source community. So first thing is avoid instant adoption. All of us have been in the IT field for a long time, so you probably know that there are some pieces of software that are published, people start using it, and then they disappear. And open source software is not very different from that. We see projects that come out when open source community starts talking about it and starts adopting them, and then they become abandoned very fast, within a few months or within a year. So open source software actually follows this pattern, even both as I mentioned here. So it's important to basically time it right, to basically avoid the adoption of software before it proves mature enough and before it proves it's here to stay. Because once you publish a piece of software to your end users, and there's always the urge for that, users will actually use it. And at ARC scale, you have thousands of servers or tens of thousands of servers, and you have thousands of users, and people will actually start adopting the piece of software you use, whether it's cloud deployment or whether it's platform as a service, the new feature in it, right away. And it's very hard to undeploy that once it's being used. And if you lose support for that because the community is no longer developing in this piece of software, or it's no longer supported, or it gets bought, it becomes a big nightmare to basically roll it out of your environment because users have already started using it. So second thing is basically talk to your customers. This is very important because once you talk to your customers, you will understand what they are doing when it comes to their projects, their workloads, and you'll probably find an open source piece of software out there that's doing the job they are doing. So instead of the one-off Python scripts, or even reinventing the wheel, writing a fully fledged project, you can actually use a piece of software that's out there to use it for your customers. One thing that comes to my mind is KF Serving, which is a new way to deliver models, basically model serving for machine learning within Kubernetes. There's lots of custom ways to do that. However, if you have a unified way of doing it, and you can talk to your customer that this is a preferred way, they'll probably adopt it, and it also helps you out because it will be less support in the future. And again, there's probably a project, as I mentioned, there's lots of projects, open source projects out there, so the custom bash scripts or custom Perl scripts are not needed, and they're basically affecting adversely your environment. And it helps you, as I mentioned, because basically a homogeneous environment is a happy environment. If you have all your customers using a single piece of software for their common workloads, and then they basically diverge out of that for their unique workloads, then that's good for you, because it actually allows you to have less support for your end users for that. And last thing is basically to get involved in the open source community. And I know many of us are very busy with our day-to-day operations. It's very hard to devote or dedicate time, but we found that even a very little time, if you dedicate that, it's a very good way to basically give back to the community. We have right now 2 personnel that are heavily involved in OpenStack, whether it's OpenStack governance or OpenStack Ansible. And we also find out that it's a good way to keep us informed of what's going on in the community. We use lots of pieces of software, as I mentioned, from open source community, so we would want always to know if there is a major change coming in that perspective. If there is a piece of software that we're heavily reliant on and it's undergoing huge changes that might affect our deployment, we want to know that because it will help us to plan accordingly within our environment. And additionally, despite the fact that Arc and enterprise workloads have become very similar in the past 5 or 6 years, Arc still has some sort of uniqueness, specifically with the scale of it, because the default deployments is thousands of servers for Arc. So it's always good to communicate the requirements and ensure that those requirements in the open source editions or open source software are actually taken into consideration instead of being left out. And this way you don't have to do one-off deployments or one-off tools to address your needs. So communicating your needs to open source community will ensure that the needs will actually continue to be met and continue to be in the mainstream releases of software. So that's basically it. Thank you very much for your time today, and I hope you stay safe in these times. And if you have any questions, I'm here to answer them.